In Chapter 16, there are several problems we need to learn how to solve, and all of them, or most of them, have to do with the concentration of a solution. We will be discussing molarity, molality, dilutions, and mole fraction. Let's start with the first. The problem asks us to calculate the molarity of the nitrate ions in a solution that contains 10.42 grams of barium nitrate, and it is dissolved in 716 milliliters of solution. So the first thing I did, as you can see, is that I converted the 10.42 grams of the barium nitrate to the number of moles. Because recall, molarity means number of moles of solid over liter of solution. So I ended up converting that to moles. The molar mass of barium nitrate is 261 grams. So I ended up getting the concentration of 0.0399 moles. The number of moles were in 716 milliliters. So I needed to have that conversion per mole. So I changed the 716 milliliters to a unit liter so that it would be in the form of molarity. And dividing that into the number of moles, I ended up getting 0.557 moles of barium nitrate. That represents the barium nitrate. Recall, I'm starting out with 10 grams of the entire salt. The question asks us, though, how many moles of the nitrate ions you have. So you must multiply your answer by 2 because there are 2 nitrate ions per salt. So I took the concentration of the barium nitrate, multiplied it by 2, and it ends up being 0.111 molarity of the nitrate ion. Okay, number 2. In order to make a 200 milliliter solution of 0.03 molarity of sodium acetate, how many grams will you need to use? Well, I used the concentration and broke it down into moles per liter. You can see that here. Instead of using the large M, I just changed the units to moles per liter, figured out how many moles I had, how many grams I had. I converted moles to grams. And then I only need 200 milliliters. So then I multiplied it by 0.200 liters, again changing it to the familiar unit liter. Notice all your units cancel, liters cancel, moles cancel. So I only need 0.42 grams of it. So I would measure out 0.42 grams and then Q up to 200 milliliters of water, and then that would be a 0.0300 molarity. Alrighty. Problem number 3. In order to make 700 milliliters of a 2.0 molarity of potassium hydroxide, how many milliliters would you need of the strength of 6 molarity? Well, this is obviously a dilution problem, and the formula for dilution is the molarity of the first times the volume of the first will equal the molarity of the second times the volume of the second. So since we have to solve for the volume of the first, we will take 700 milliliters, multiply it by the strength of 2 molarity, and then divide it by the 6 molarity strength, and it ends up being 230 milliliters. For sig figure reasons, we probably should have the answer 200. So we will need 200 milliliters of the 6 molarity strength. We will add 500 milliliters of water to dilute it, giving us 700 milliliters of a 2.0 molarity. Number 4. Calculate the molality of a 2.21 gram solution of a sodium chlorate, and the amount of water used is 25.31 grams of water. Be careful. It says molality That one little letter changes everything. Different calculation, and basically it is the solvent that is different. Still calculate the number of moles of solute, but it must be per kilogram of solvent. So, again, since it says number of moles, we have to convert the 2.21 grams of the sodium chlorate. Notice I didn't write the chlorate in because I thought I'd run out of space. Anyway, the mass of the sodium chlorate is 106.5 grams is a mole. So we end up with 0.0208 moles of the sodium chlorate, and we change the 25.31 grams to kilograms, which means you basically divide it by 1,000. And now we have the units. Moles of solute over kilogram of solvent. Dividing, we end up getting 0.822 molality. I need to move the paper to get to the next two problems. Okay, problem number 5 is another molality. It asks us what mass of the ammonium nitrate will yield 0.886 molality, and the solution will be 339.8 grams of water. So using that same formula, the 0.886 molality is going to be how many moles of the ammonium nitrate over kilograms. So we ended up getting 0.301 moles. Converting moles to grams, I would have to have 24.1 grams of the ammonium nitrate to be able to have 0.886 molality solution, only using 339.8 grams of water. The last problem is mole fraction. And mole fraction is basically parts per whole. So the formula is the number of moles of A over the number of moles of A plus the number of moles of B. So we'll make A the carbon disulfide and the B the carbon tetrachloride. Now notice we have to convert those grams to moles. So here shows the calculation of 44.5 grams being converted to moles. So that's how many moles we have of the carbon disulfide. So I'll place it in the numerator. That's A. And then I'd solve for the number of moles of carbon tetrachloride, 1.39 moles. So it goes in the denominator as B along with A. So in adding it up and dividing, I ended up getting a mole ratio of 0.295. All right, we have 2 more problems to do on Monday, and hopefully we'll be ready for our test. Good luck.